Okay, I'm looking at example 12C, Math 64, Chapter 8 on page 72, and I want to explain what your book is doing to solve this problem, and then I'll present for you what I think would be a good idea, or an alternate idea, let's call it that. So I have this nitroprusside, I don't know if I'm saying that right, and this is the strength in which it comes, 250 milligrams per 50 milligrams per 250 milliliters, and this is the rate at which it's running. Okay, the patient weighs 65 kilograms, and oh, by the way, when I look at this guy here, this 5 micrograms per kilogram, what catches my eye is this right here, that kilograms. That tells me that I'm probably going to be using weight somehow in there. And sure enough, that's the next thing they give me in the problem, that the patient weighs 65 kilograms. So the nurse is using a type of tubing that's 20 drops, I should say, per milliliter. So here's the first question. This is question number 1. What's the milligram per minimum dose? And then question number 2 over here. Number 2 is, what is that in terms of hours? So here's what your book does. They start off with 65 kilograms, the weight of the person. And what they're doing is they're using this conversion right here, and they're going to multiply the 65 by 5 micrograms, because it's 5 micrograms for every kilogram. And they get a total of 325 micrograms per minute, because those are the units right here. And then what they do is they include this step, which I don't like because they shouldn't give you multiple things in one row. But they're taking that answer and they're multiplying it by 1,000 in order to get milligrams, which is what the question was asking over here. They wanted to know how many milligrams per minute is the dose. So this is the answer to question number 1. Okay, then they take this and they're going to get the answer to number 2, which is to figure out what it is milligrams per hour. And here they went ahead and set up a proportion, which is just fine. They take the answer, you know, there's a typo here. This is supposed to be 325. Let me put a little 5 in there. Okay, so they take the 0.325 milligrams per 1 minute, and they say, well, what is that going to be for 60 minutes, which is an hour? And so one way to think of it is, well, what do you do to the 1 to change it to 60? And I don't like the fact that they're showing both of these things in here, minutes and hours. Really don't need this, okay? Because you want to know what it is for 60 minutes. So what do you do to go from 1 to 60? Well, you multiply by 60. And if you're going to multiply the bottom by 60, you have to multiply the top by 60. And so this is the answer that they get. So 19.5 milligrams per hour is the answer to question number 2. Number 2. Okay. Then they're asking, what's the milligrams per, or what's the milliliters per hour? Milliliters per hour. And then they're asking for the drops per minute, which is going to be the drop rate. This guy right here is my drop rate. Okay, so I'm going to work on the first part. So they want milliliters per hour. Well, what do I have? I have milligrams per hour in this question right here. So somehow I'm going to have to change from milligrams over to milliliters. Well, there's a thing in the original problem right here, that does go from milligrams to milliliters. So what they've done is they've taken that information right here and they've actually divided 250 into 50, and so they think of it as simplifying that. So from that they get that it's 0.2 milligrams per milliliter. That's the strength. So what they did is they took the answer 19.5 milligrams per hour, put it right here, right there. And then they took this conversion over here, milligrams to milliliters, and they put it right here. Okay. And so I want you to notice by doing this, they're actually knocking out those units. And so if you divide 19.5 by 0.2, you're going to get 97.5. And notice that it's milliliters over hours. Now you might say, well, how on earth did that happen? Because it's hours over milliliters. Well, let me show you how it happens. I'm going to rewrite that. It's 19.5 milligrams, and I'm going to do it this way. I'm going to say for 1 hour, okay? Milligrams per hour. And remember, this guy over here, this guy right here, that's just nothing more than one big division problem. So I'm just going to say divided by. And then I'm going to put the second part of that in, which is 0.2 milligrams for 1 milliliter. Well, this is a fraction divided by fraction. And if you remember your rules for dividing fractions, the first guy stays the same over 1 hour times, and now this guy gets inverted, okay, that he comes up on top and this guy goes on the bottom. So it's going to be 1 milliliter for 0.2 milligrams. Well, look what happens. The milligrams drop out. They drop out. You end up dividing 19.5. You end up dividing that by 0.2, right? Which is what they did right over here, right there. And they got an answer. They got an answer of 97.5 when they did that division. And the units that remain are milliliters on the top and hours on the bottom. Hours on the bottom. Okay, so that's how that happened, because initially we would look at this and say that these units here should be hours over milliliters, but they're not, and it's because of what I just demonstrated. Okay, so finally your book is saying, let's go ahead and find the number of drops per minute, which is the drop rate. And so they're following this formula. This is what it is for 1 hour. Okay, you have this formula, and it's times the drop rate in milliliters, the drip rate in terms of milliliters. Sorry, a drip and drop is kind of confusing. And it's we want it in minutes, so we have 60 minutes down here, and let's just forget about all that. So if you have 97.5 and you multiply it by 20, and let me make sure that that's correct. 97.5 times 20. Okay, so I get, and divided by 60. Okay, 32.5, so I agree. So you get 32.5. 97.5 times 20 divided by 60 gives you this. Now, look what happens on the units is the time is now minutes. He came from down below here. And the upper part is the drops, GTTS, and the milliliters dropped out, and the hours, that was just one, so we don't have to pay attention to that. So that's an explanation of what your book is doing, and I'm not really wild about it. It appears a little disjointed to me, and so I'm going to redo this, and I'm going to do it using conversion chain.